In this video, we will study limits of the form. The limit as x approaches O of x to the n minus a to the n over x minus a. This is a classic limit that comes up all the time in algebra and calculus. Here is the limit we want to evaluate. Notice that if we plug in x equals a directly, we get 0 over 0, which is indeterminate. That tells us we need to simplify first. The key tool is the factorization formula for x to the n minus a to the n. It factors as x minus a times a sum of n terms, starting with x to the n minus 1 and ending with a to the n minus 1. Now substitute that factorization into the limit. The x minus a cancels, leaving just the sum inside the parentheses. Now the expression is continuous, so we can plug in x equals a. Each term becomes a to the n minus 1. And since there are n terms total, we add a to the n minus 1 n times. So the final result is the limit equals n times a to the n minus 1. Let's do a concrete example. Example 1. The limit as x approaches 2 of x cubed minus 8 over x minus 2. We factor x cubed minus 8, cancel, and then plug in x equals 2. Example 2. The limit as x approaches 5 of x squared minus 25 over x minus 5. This is a difference of squares. It becomes x plus 5, and plugging in 5 gives 10. Finally, here is the geometric intuition. The limit we computed is actually the slope of the tangent line to y equals x to the n at x equals a. We'll illustrate this with y equals x cubed at it equals 1. At x equals 1, the slope of y equals x cubed is 3 times 1 squared, which is 3. That matches the tangent line we see. So this limit formula is really giving the derivative of x to the n at x equals a. To summarize, the limit of x to the n minus a to the n over x minus a is n times a to the n minus 1. This comes from factoring, canceling, and then plugging in x equals a.